In this lesson, we are going to go over analyzing graphs of functions. From the graph of the function, we'll be able to write the domain and range of a function in interval notation. We'll identify intervals where a function is increasing, decreasing, or constant, and then we'll understand relative maximum and minimum. So first, increasing, decreasing, and constant. Increasing means that as x values get bigger, y values also get bigger. So our graph is going up. Decreasing, as x values get bigger, y values get smaller, our graph is going down, or the function is going down. Constant, as x gets bigger, y is staying the same, so you'd have a horizontal or a flat line. When you're determining intervals where the graph is increasing, decreasing, or constant, you want to make sure you read the graph from left to right, and we'll talk about the importance of that in our example. So example 1, list the intervals on which the function is increasing, decreasing, and constant. So just as we start looking at the graph, I said we read it left to right, so we'd start on the left-hand side. The function goes down, so decreasing. Goes up, increasing. Stays the same, constant. Goes up, increasing. Goes down, decreasing. Okay, so notice, let's say from here to here, so from x negative 1 to 3, our graph is going up. And notice that the y values are getting bigger from negative 2 to 4. And you can do the same with decreasing and constant. Okay, when you write your intervals, you're going to talk about or write the x values in the intervals where the graph is increasing, decreasing, or constant. Okay, so these x values are telling you where the function is increasing, decreasing, or constant. And our intervals are always open. For instance, at this point, we can't say exactly what's happening here, so we leave it open. If you want to know more about that, the answer comes from calculus, and I'll be happy to talk to you about that. But remember that increasing, decreasing, and constant, when you're writing it in interval notation, use parentheses or open intervals. Okay, so first for increasing, it's where our graph is going up. So it goes up from x negative 4 to negative 3. And then it also goes up negative 1 to 3. Okay, and again, these are x values, and the instructions say to list the intervals, so we'll separate our intervals using commas. Decreasing is where the graph is going, or where the function is going down, so it goes down from negative 6 to negative 4. And then also from 3 to 6. Okay? And again, these x values are telling us where, or in what interval, the function is exhibiting increasing, decreasing, or constant. Okay? For constant, we have from here to here, I'm writing it in purple, x goes from negative 3 to negative 1. Okay, so these would be the intervals that you would list for each of the respective categories. Example 2, list the intervals on which the function is increasing, decreasing, and constant. So increasing again is where our graph is going up, or where our function is going up. Okay, so it starts here at 2, and this keeps going on forever and ever and ever and ever and ever. Okay. Which means that the x values are going to get bigger. So our first endpoint is 2, so it starts to go up at 2, and then it keeps going. So this would be from 2 to infinity. For decreasing, we have our graph going down. So again, this is going to keep going on forever and ever and ever and ever. There's no endpoint there. So that would be large negative x values, negative infinity, and then it goes all the way to x is negative 1. Okay. And then it's constant where there's a horizontal or flat line. So this would be from x negative 1 to 2. Okay, so it's increasing from 2 to infinity, decreasing from negative infinity to negative 1, and constant from negative 1 to 2. Next, relative maximum and minimum. So hills and valleys of a graph. So the hills are the relative maxima, and the valleys are the relative minima. Okay. Whenever I talk about this, so I'm from northern Nevada where we have Lake Tahoe, so mountains, and then I'm from the valley that's right under it. So you've got a hill, and then you've got a valley. Okay, so something like this. So these points on the hill would be the relative maxima. This valley here would be the relative minima. There can be more than one. So this function that I just drew has 2 relative maxima and 1 relative minimum. Okay. Something to note is that the x-coordinate of the relative max or min tells us where the relative max or min occurs, and the y-coordinate of the relative max or min tells us the relative max or min value. So for instance, if we have an ordered pair here, let's just say this is 1, 3, it occurs when x equals 1, but the relative max value there is 3. Let's do some examples. So using the graph, determine any relative maxima or minima of the function. So let's first identify the relative maxima. We have 1 here, okay? It's only at the top of the hill for the relative maxima. So for instance, this point here, even though it's higher up, is not a relative maxima, okay? It has to be a hill. So this occurs, the relative maximum value, so value is the y value, is 1, and that occurs when x is 2. Okay, so this is how you would answer this question. The relative minimum, so again, this is a valley. The bottom of the valley is your minimum. Right here, again, it's not this, even though this is lower, it's not a relative minimum, okay? It's the bottom of the valley. So the value is -2, and it occurs when x is -1. Next example, this should say example 2. Using the graph, determine any relative maxima or minima of the function. So first it's asking for relative maximum. So there's only 1. The value here is 3, and it occurs when x is 1. Okay. The relative minimum, in this case it's minima, plural of minimum, because there's 2. We have 1, 2. So the values here are 1 and -2, and that occurs, so 1 happens when x is -3, and the value of -2 happens when x is 4. So in this case, there are 2 relative minima. Putting it all together, so some questions may ask you to put everything we've talked about, increasing, decreasing, constant, max, min, relative max, min, and domain and range together. So we'll do a few examples of that. So first, list the intervals on which the function is increasing, decreasing, and constant. Determine the domain and range. If it's not showing up super well, there is a spot on the graph. There is part of the graph that goes from 2 to 3. Okay, so increasing, decreasing, and constant. So increasing is where, I zoomed in and now. Okay, increasing is where our graph is going up. So it goes up again. This would continue on forever and ever and ever down. Okay, so it goes up from x -infinity all the way to x 0. And then it goes up again from 3 and it stops. So this is not going off the page. I should have put an endpoint here. Pretend it's there. It's not going off the graph. Okay, and so this goes from x is 3 to 8. Again, these are telling us what x values are where the function is increasing. Decreasing is where our graph is going down. Okay, so notice at the top of one of these hills, the graph is switching from increasing to decreasing. Okay, same thing with the valley, it switches from decreasing to increasing. That also has to do with why we deal with relative maximum and minimum as hills and valleys as well. So decreases from 0 to 2, and then it's constant from 2 to 3. Okay, the domain is all the x values of the function, so I'm going to erase my writing. Okay, so the domain is the smallest x value, and again, we had talked about that this graph, it's running off the page, so we assume it keeps going on. As it keeps going down, the x values are going to get more and more negative, so this is -infinity. Okay, and as we move from left to right, our largest x value is x is 8. Okay, the range is the smallest y value to the largest y value, so again, our smallest y value is where this part of the function keeps going down and down. The y values are getting more and more negative. This is -infinity. And then the highest y value on our graph occurs here, okay, at the top of this hill. So the y value here is 4, and it gets a bracket. And I'm sorry, the domain should also get a bracket, because there is a point here at 8. It's not an open circle. Okay. The range is -infinity to 4, bracket, and the domain is -infinity to 8, bracket. Let's do another one. Determine the domain and range and the relative maximum and minimum values. So domain and range. So again, this is a parabola. It's our upside down U. and it's going off the graph. So it's going to keep going on and on and on. It's going to keep going down. So when we look at our x values, it's going to keep getting more and more negative. So that's negative infinity. We keep going left to right, left to right. It's going to keep going. And these x values, even though the graph is going down, these x values are getting bigger and bigger in the positive direction. Okay, so our domain here is negative infinity to infinity. The range is our smallest y value to our largest y value. Again, the graph is going to keep going down, which means the y values are getting more and more negative. So this is negative infinity to the highest y value is 7.2. Okay, and since there is a point there, the graph is filled in, there's no open circle, it gets a bracket. The relative maximum value, so when you see this word value, it's talking about the y coordinate of the relative max. Our relative max is here at the top of the hill, so it's 7.2. And for relative min, there is none. Okay, there's no values present on this graph. So example 3 is an application problem. So the graph shows the kilowatt hours of electricity used on one morning in a local household. So kilowatt hours is a measure of energy. So let's say you have a power drill that's 1 kilowatt. If you were to run that power drill for 1 hour, that's 1 kilowatt hour. Okay, so it's a measure of energy. It's also, if you don't pay your power bill yet, one day when you may pay your power bill, you're charged based on kilowatt hours. Okay, so that's where that comes into play. So first it's asking for the domain and the range. So the smallest, our x-axis in this case is time. Our y-axis is usage. So at 8 a.m., this household used 0.32 kilowatt hours. At 10 a.m., 0.145 kilowatt hours, and so on and so forth. Okay, so our domain here, our smallest value on the independent axis or the horizontal axis is 8, and there is a point there, so it gets a bracket. And our largest is 11, and again, there's a point there, so it gets a bracket. Our range is our smallest value in the vertical axis, or the lowest usage, to the highest usage. Okay. So the lowest usage is 0.145 and the highest usage is 0.701. Both of those get a bracket because there are points there. Okay. Next, we are asking which hour was the most power used and which hour was the least power used. So it's talking about hours, which is our horizontal axis that represents time. So the most power was used here, and that corresponds to 9 a.m. When was the least power used? This corresponds to 10 a.m. Okay, so probably in this household, everybody's getting ready and leaves at 9 a.m. Okay, and everything shuts off, or they're not using as much electricity. Okay. Let's call this function r. What's r of 8? So 8 is in the input position, so we are looking for 8 on the horizontal axis and finding the corresponding y value, if we want to think of it that way, or the corresponding usage. So r of 8 is 0.32. And then it's asking during what time intervals did electricity usage increase. So we increased from 8 a.m. to 9 a.m. and then again from 10 a.m. to 11 a.m. Okay, and remember these are written as intervals with parentheses. Thank you for watching. If you have any questions, feel free to reach out to me.